Okay, so when we look at example number 7, we're going to have calcium hydroxide. So we know calcium here has a 2+ charge. We know our hydroxide here has a minus charge crisscrossing those. We know that we're now going to have 1 calcium to 2 hydroxides. Plus our next part here is going to be phosphoric acid, which I actually had to look up. So H3PO4. And we're going to produce or yield calcium phosphate, calcium again having a 2+, and our phosphate, our PO4 here, having our phosphate here actually has a 3- charge. So crisscrossing those, I know I'm going to have 3 of those and 2 of those. So I'm going to get rid of my charges here. And my last portion, which I have to slide over a little bit on the board here, okay, if I were to add these two together, I would have water. One of the common ways to write water when dealing with hydroxide ions is HOH. Charge on a hydrogen we know is positive, OH is minus, so that's going to be at a 1-to-1 relationship. So now looking at these, let's start our tally. So we have calcium over here. Calcium I know I have 1 of. Hydroxide I can treat as a standalone, so I know I have 2 of those. Hydrogens I can treat as a standalone, so I know I have 3 of those. And my phosphorus, my PO4, I know I only have 1 of those. Looking at my product side, I have calcium, which I have 3 of. I have my hydroxide, to keep these in order, I have 1 of. And get rid of those charge. H's, I have 1 of. And PO4s, treating the whole thing as an entirety, I have 2 of. So looking at these, the biggest problem I see is between the hydrogens. So the hydrogens, I have 3 and 1. What I like to do when I have an odd number is try to make them even. The easiest way to do that is to multiply this by 2. So now I'm going to end up with 6 hydrogens, and I'm going to end up with 2 phosphates. Well, the nice part about that is it balances out my phosphates here, but I need to start multiplying more hydrogens. So looking over here at my HOH, if I were to put a coefficient of 6 out in front here, it would now suffice for having 6 hydroxides and 6 hydrogens, which is problematic because of switching to this side. Well, the other problem here is that now I need to have 6 hydroxides. Well, how can I have 6 hydroxides? Well, I have a multiple of 2 here, so what times 2 gets me to 6? Well, if I put a coefficient of 3 out in front, 3 times 2 gives me 6. And now I actually end up with 3 calciums. So to check over our answers, I have 2 phosphates, 6 hydrogens, 6 hydroxides, and 3 calciums. Sufficing for our answer for example number 7.